Alright, so in this unit we're talking about one variable equations. So the first thing we're going to start off with is a one-step equation. So what I like to do is I like to imagine that is a note card over the variable. So our first step on number one, remember you always want to do the opposite when you're solving for the variable. So when we want to get x by itself, we want to cover x up and get rid of everything else. So the opposite of adding a 12 is subtracting 12, and what we're going to do that to both sides. So pretend there's a mirror right here. We're going to do the same thing to each side. So I'm going to draw my mirror for all of them. That way I can keep the color the same. Alright, so we have 10 minus 12, which is negative 2. This 0 pairs out. And now I'm going to erase my little, I'm going to call it a note card. Okay, so I'm imagining there's a note card. And so when I get m by itself, that is my answer. M equals negative 2. And I can always check this. You always want to check. Algebra is so fun because you can always check. So if you were to put negative 2 where m should be, you have negative 2 plus 12, which is 10. Alright, we're going to do the same thing with number 2. We're going to cover up, put our little note card over G. We have minus 9, so a positive adding 9. So that 0 pairs out. Negative 2 plus 9 is 7. And so the only thing I have left to do is bring down my G. So 7 equals G. And I can check that to make sure. So where G was, we're going to put 7 minus 9. Does that equal negative 2? That's a check. So that's what it means by checking. Look how easy it is to make sure that your answer is correct. Alright, number 3. This one, you can't put a note card over the y because that's what part you're working with. You're multiplying by negative 7. So remember, when things are really close together, it's considered to be multiplying right there. So what's the opposite of multiplying by negative 7? Dividing by negative 7. And so I want to divide each side by negative 7. So I have y equals negative 91 divided by negative 7 is 13. So that's my answer. I'm going to put in checks. I have negative 7 times 13. Does that give me negative 91? Negative times negative is a negative. Negative times a positive is negative. 7 times 13 is 91. Oops. Did not mean to do that. Last one. We have a divided by 8. Alright? So, I want to do the opposite of dividing by 8, which is multiplying by 8. So that one's out. Multiply by 8. I get a equals negative 4 times 8 is negative 32. I can check my answer. Negative 32 divided by 8 equals negative 4. Is that true? Yes. Alright, so now we're going to talk about two-step equations. Two-step equations are where it gets a little bit tricky. But I like to put a note card over my variable. So I'm going to put my little note card over my variable, so where I can't see it anymore. Alright, and the coefficient that's with my variable. And I'm actually going to do that for all the problems. Just go ahead and do that. I like it. Okay, because you always want to work with that part last. I'm not going to do number 4 because I want to talk about that later. So we want to get rid of the plus 8 first, so we want to subtract 8. Let me put my little mirror up. What I do to one side, I do the other side. Subtract 8. I get 42 equals, this is where the note cards comes into play. You don't have to worry about the 6 until now. And so we're multiplying by 6, the opposite of multiplying by 6, dividing by 6. So we get x equals 7. So we can check that. We can check 6 times 7. That's our x. plus 8 equals 50. Order of operations says do these first, which is 42 plus 8 equals 50. Is that true? Yes, it is true. Let's look at number 2. So this one, remember, we had 2n minus 5, but we want to put our little bookmark over our 2n. And we want to just deal with the minus 5 first. The opposite of minusing 5 is a positive 5, adding 5. So we get 16, that zeroes out. Now we want to remove our note card. We have 2n equals 16. Divide by 2. We get n equals 8. Alright, now we want to check. We always want to check. Algebra is one of those great things where you can just always know if your answer is right, because you can always just plug it in. So we have 2 times 8 minus 5 equals 11. Well, order of operations says 2 times 8 first, which is 16. Minus 5, is that 11? Yes, it is. Number 3, we have negative 4k plus 9. So I'm going to put my bookmark over that one. I'm going to subtract 9. We have 4 equals, take my bookmark off, negative 4k. So now, what's the opposite of multiplying by negative 4? Well, it's dividing by negative 4. So that one's out, so the only thing left on that side is k. 4 divided by negative 4. Well, 4 divided by 4 is 1. A positive divided by a negative is a negative. So our answer is negative 1. So we can plug it in. So we have 13 equals negative 4 times negative 1 plus 9. So negative 1 is my x. So negative 4 times negative 1 is 4 plus 9. That gives me 13. Is 4 plus 9 13? Yes, it is. Alright, number 4 is a little weird. This is where the note card comes into play. You always want to deal with the number that's multiplying by your variable or dividing by your variable last. So I'm going to put a note card over all of that, including the sign that's in front of it. Because that minus sign doesn't go with the 7. It's minus 3. 5 minus 4 isn't the same as 4 minus 5, so they're not interchangeable. In addition, it's kind of interchangeable, but subtraction, it's not. So I'm going to cover up all that. So I'm adding the 7. I have a positive 7, because this is positive. The opposite of that is subtracting 7. Alright, that zeroes out, so I'm left with 34 minus 7 is 27. Now I want to take off my card. I have negative 3. Why? Opposite of dividing or multiplying by negative 3 is dividing by negative 3. So we have y equals 27 divided by 3 is 9. A positive divided by a negative is a negative. If you would have added 7 first, you would have had, 41 divided by negative 3, which would have given you a different answer. And we want to check our answer. So we have negative 7 minus 3 times negative 9, because that's my y. So we have 3 times negative 9, which is negative 27, equals 34. When you subtract a negative, it's just adding. 7 plus 24, or 27, is 34. Does 34 equals 34? Yes, it does. Alright, I'm going to do number 5 and number 6, and then I want y'all to do 7 and 8 before you come into class. So on number 5, let's put a card over our x, put our line. We have subtracting 7, so we're going to add 7. Add 7. Alright, then we're going to take our card off. We have x divided by 2. The opposite of dividing by 2 is multiplying by 2. This is the one that people have the hardest time with. Just think, what are you doing to x here? Well, I'm dividing by 2, so that means I have to multiply by 2. So we get x equals 32. And let's see if this works. Does 32, which should be our x, divided by 2 minus 7 equal 9? Well, 32 divided by 2 is 16 minus 7. That does give us 9. Okay. Last one. We're going to put over our variable and whatever is happening to our variable. We are going to subtract 8 from each side. Remember the little mirror. That zeroes out. We have 33 minus 8 is 25 equals, take your note card off. If I were in class, I would be physically putting a note card over all these. C divided by negative 5. What's the opposite of dividing by negative 5? The opposite is multiplying by negative 5. Okay, we don't want to divide 25 by negative 5. We want to multiply by negative 5. Always do the opposite. So when we do that, we actually get that C equals 5 times 25 is 125. Negative times a positive is a negative. So C equals negative 125. Remember, you can always check this. You should always check it because it will let you know if you did it wrong. So it's kind of like free questions. We have negative divided by a negative is a positive. 125 divided by 5 is 25. Is 25 plus 8 33? Yes, it is. Alright, so do number 7 and number 8. Come back into class later. And we will do those as our warm-ups.